Alright, welcome to this video. In this one we're going to be talking about quadrilaterals and congruence. So we've also looked recently at the idea of triangles and congruence, regular figures and congruence, but we want to spend a bit of time talking about quadrilaterals and congruence because we use the triangle congruence rules we looked at just in our previous video to prove the properties of special quadrilaterals. Okay, so if we have a look here in parallelograms, right, this here, unsurprisingly, is a parallelogram. So if we have a look here, essentially this video is going to be more about in-depth looking at these shapes. We've seen them before, we've looked at calculating areas of them, but for this one we're going to concentrate on the specific properties of each one. Okay, so we've got parallelograms. Right, we've got opposite sides and opposite angles are equal. So I want to have a look at why that is. Okay, so actually no, this is going to be an example for parallelograms in the congruence examples video, which is next one. So I just want you to take this as it is at the moment. So opposite sides and angles are equal. So remember, these double dashes here mean that we've got the same length here and here. These ones here mean the same. And the other one here is diagonals bisect each other. So this word bisect means that they cut each other in half. Okay, so cut in half. Right, so this line here cuts this one here in half. Okay, so this point here is the midpoint along both of these lines. Okay, this is a really important one. Okay, it's moving on down into the rhombus. So with our rhombus here, we've got a couple of different properties. So our opposite angles are equal. Okay, so firstly you're aware that with a rhombus it's essentially a parallelogram, but we have all the sides are equal in length. Okay, and two of them are parallel, two of the other ones are parallel. Right, so opposite angles are equal. So this one here is equal to this one, and this angle here is equal to this one here. Okay, additionally, our diagonals not only bisect at 90 degrees, but they bisect the interior angles as well. So if we look at this one here, okay, if we were to zoom that in, let's just draw a quick little version of that here. Okay, there's that angle, the bisecting line coming down through here. Right, when we're looking at that, what it's saying is that this here is theta, some angle, and on the other side of the diagonal is also theta. They're exactly the same. Okay, so these two pieces are exactly the same as on here. These two pieces, either side of the diagonal, exactly the same angle. Okay, it's our rhombus. Right, let's move on to the rectangle. Right, with the rectangle, couple of different things. Opposite sides are equal, similar to the parallelogram. So these two here are equal length, these two here are equal in length. Our diagonals bisect each other again. So this here is the midpoint of both lines. Okay, and our diagonals are equal. This length here is the same as this length here. And additionally, like with the rectangle, you need to remember that we've got right angles in our corners and that kind of thing. Okay, so even though the diagonals bisect each other, unlike the rhombus, they don't bisect the angles. Okay, so just be careful with that one. Okay, square. You're probably really familiar with the good old square. So we've got equal diagonals. So similar to the rectangle, these lengths here are the same. And they also bisect each other here, and like the rhombus, they bisect each other at 90 degrees as well. Okay, remembering that a rhombus is just a square, it's kind of been squashed a little bit. The diagonals also bisect the interior angles. Okay, so I mean they're 90, diagonals are always going to bisect to leave 45 here and 45 there. Okay, so squares, sort of quite simple, you'd be quite familiar with those. Right, trapezium, sort of the odd one out of our special quadrilaterals. So we've got one pair of parallel sides, so here and here, okay, parallel, not equal in length, and we've got these extra sides here, they're not equal in length either. So really the main thing you need to worry about trapezium is that these are parallel, okay? Diagonals don't bisect each other. They don't bisect the angles that they're going into. So you need to be very careful with the way that you approach them and the kind of rules that you use to work with the trapezium, okay? Because really this parallel nature is about one of the few things that you can grab with them, okay? Right, the kite. Okay, so we've got one pair of opposite angles are equal. So this angle is equal to this one. However, this end here is not equal angle to that one there. Okay, so we need to be careful with our kite. Our diagonals intersect each other at right angles, like our rhombus. Here we have right angle, right? But only one diagonal is bisected by the other. So the long diagonal, the one going this way, bisects the one going this way. So this length here is the same as this one on this side. Okay, that's the same as that on our kite drawing here. Okay, so equal lengths here, equal lengths here. This is a bisected angle, and this is a bisected angle as well. Okay. But these ones here aren't. So there's a lot of really interesting things going on with the kite. So you need to be very careful with the way that you approach your understandings of them. Okay. So this video really just went through a bit more in depth some of the properties of these quadrilaterals. I do have a video coming up next that talks a little bit more about some examples of using these congruence rules to answer some questions, okay? So please watch this video again if you feel like you need to, and come along to class with any questions. Thank you.